Hey everyone, and welcome to our deep dive today, all about generative AI. Specifically, we're going to try and get a handle on all the core math concepts.
That drive all this amazing AI stuff that's happening right now.
Exactly. And our source material, this PDF called Generative AI Math, it's like a mini course. It's fantastic.
It is a really good overview, and it's so true what you're saying about the math. It really is the bedrock of AI
Right.
because it's how we actually build and understand and then refine all these powerful AI models that are doing such cool things.
Okay, so let's just get to the basics first. What is generative AI?
So you can think of it as AI that can create new data, new stuff based on the data that it's been trained on.
Okay.
Like, let's say, an AI model that's been fed a bunch of Van Gogh paintings
Oh, cool.
could then learn to paint like Van Gogh, that kind of thing.
Wow, that's so
Or write
interesting.
like Shakespeare after analyzing all of his works.
So it's like it's learning the essence of something and then using that to create something new in that same style.
Yeah, that's a really good way to put it.
That's wild.
Yeah, and the impact of this, it's not just art. We're seeing it in things like drug discovery.
Oh, wow.
Like there's this model called AlphaFold that's been making huge waves,
Yeah, I've heard of that one.
really revolutionizing things
Right.
because it can predict these complex 3D structures of proteins,
Huh.
which is a huge deal for figuring out how to make effective drugs and treatments.
Right. Yeah, it's not just like making cool paintings.
It's impacting all sorts of
That's
fields.
like real science and stuff.
Exactly. Even things like writing super realistic dialogue for chatbots.
Oh, interesting. So how does math play into all of this? Because I know it's really important.
Yeah, math is really the language of AI.
Okay.
It's how we can build these crazy complex models and understand what's going on inside them.
Got it.
There's some key areas: probability and statistics, linear algebra, and calculus.
Okay, so let's break those down one by one, starting with probability and statistics. I kind of remember a little bit from school,
Right,
but
right.
what does that have to do with AI?
Well, you can kind of think of it as like the logic of AI.
Okay.
It's what helps AI models understand patterns in data and make decisions.
Hmm.
Like, for example, you train an AI model on a ton of images of cats and dogs.
Right.
Then it can use probability to figure out,
If a new image is a cat or a dog.
yeah, exactly.
Oh, so it's like making an educated guess.
Yeah, exactly. It's like how we might use probability to figure out, like, the chances of winning the lottery.
Right. Or like flipping a coin.
Exactly.
Yeah.
And of course, sometimes it gets it wrong.
Yeah.
But the more data it's trained on, the better it gets.
The better its predictions get.
Right.
Got it. Okay, what about linear algebra? I vaguely remember matrices, but how does
Yeah.
that apply to all this?
So that's all about working with data structures, and it's how AI is able to process and manipulate these massive amounts of information.
Okay.
So like an image can be represented as a matrix, which is basically like a grid of numbers representing the pixel values. And then AI algorithms use linear algebra operations on these matrices to identify patterns and features.
So matrices are like the building blocks of how AI sees an image.
Yeah, that's a good way to think about it.
Cool. Okay, and calculus. That one always seemed a little intimidating in school.
I know, calculus, it sounds scary,
Yeah.
but it's all about change and optimization.
Mm.
And in AI, it's used to make the models as accurate as possible.
Right.
One important concept there is gradient descent,
Oh, yeah, I've heard of that.
which uses calculus to find the best values for the parameters in a model.
Okay.
It's kind of like, imagine trying to find the lowest point in a valley.
Okay.
You take these small steps downhill, and you're constantly adjusting your direction based on the slope.
Right.
Calculus helps AI do that to find the optimal settings.
So those three areas of math, probability and statistics, linear algebra and calculus, they're kind of like the core of how these AI systems learn and make decisions.
Yeah, they really are the foundation for all of this.
That's really helpful to know. Okay, so we've got the definition of generative AI and the key areas of math. Now I want to know how AI has actually evolved over time. Like, how did we get to where we are today?
Oh, that's a great question. And the history of AI is actually pretty fascinating
Okay.
because we've gone from these really simple rule-based systems to the incredibly sophisticated generative models that we have today.
Right. Yeah, I'm ready for a little AI history lesson.
Perfect. Let's go back in time and see how it all started.
Let's rewind the clock.
All right. So way back in the 1950s and 60s,
Mm-hmm.
the earliest forms of AI
Okay.
were known as symbolic AI. And these systems relied on like predefined rules and symbols
Mhm.
to try to mimic human reasoning.
So it's kind of like teaching a computer to play chess by giving it the rule book.
That's a great analogy, exactly. But
Mhm.
symbolic AI had its limitations.
I bet.
Yeah, it struggles with the complexity and the ambiguity of the real world. And then in the 1980s and 90s, neural networks came along.
Oh, yeah, I've heard about
Yeah,
those.
these were inspired by the structure of the human brain, and they kind of revolutionized AI by letting machines learn from data.
So this is where the idea of AI actually learning from experience rather than just following rules really started to take off.
Exactly, it's a huge shift, and a key turning point during this period was the invention of this algorithm called backpropagation.
Backpropagation. Oh, right.
It allowed us to train these neural networks much more effectively
Oh, wow.
by adjusting the connections between artificial neurons based on the errors they made.
So before backpropagation, it was really hard to train these complex
Yeah,
networks.
it took forever. It was a real bottleneck.
Wow. So this backpropagation algorithm really unlocked the potential of AI, huh?
They really did. And then the 2000s, we saw machine learning and data-driven approaches becoming more prominent.
Oh.
So AI became less about programming explicit rules and more about letting algorithms find patterns in data.
Hmm.
And then that brings us to the 2010s and the present day, the era of deep learning and massive data sets.
Yes, the era we're living in.
Exactly. And this is where things get super exciting with generative models like GANs taking center stage.
Yans, I've heard so much about those.
They're pretty amazing.
Yeah, those are the rock stars of creating new data, right?
They are, and they're actually quite interesting how they work.
How do they work?
Imagine like two AI models in this constant creative battle.
Oh, wow.
That's basically you've got a generator network
Okay.
that's trying to create realistic data, and then you've got a discriminator network
Oh,
that's trying to figure out if the data is real or if it was made by the generator.
interesting.
So the generator is constantly trying to fool the discriminator,
Okay.
and the discriminator is trying to get better at spotting fakes and back and forth
Yeah.
leads to some really incredible results.
So they're kind of pushing each other to get better and better.
Exactly.
That's really cool. And Jans are responsible for some of the really impressive stuff we see today.
Yeah, like the photorealistic images.
Right. And then there was something else mentioned in our source material, VAEs.
Oh yeah, VAEs or variational autoencoders.
Yeah, how are those different from Jans?
So they work in a different way. Instead of that kind of back and forth battle,
Okay.
it's more like they're master code breakers.
Oh.
They learn to compress the data into this smaller representation, like a code.
Right.
And then they use that code to reconstruct the original data.
Ah.
And through that process, they learn how to generate new data that's similar to what they were trained on.
So they're learning the essence of the data and using that to create new but similar stuff.
Exactly. And they're really good at things like generating images, reconstructing incomplete data,
Mm-hmm.
and even detecting anomalies.
That's pretty useful.
It is, but there are other types of generative models too.
Okay.
Our source mentions these things called normalizing flows, which are a bit more complex,
Okay.
but they're really powerful.
Mm.
They involve transforming simple probability distributions into more complex ones.
You're right.
They can model real-world data more accurately. It's kind of like,
Give me a simple analogy.
okay, so imagine you have a lump of clay.
Okay, if I've got my clay.
It's easy to work with,
Right.
but limited in the shapes you can create.
Right.
Normalizing flows are like a set of tools that let you mold that clay into these crazy, intricate sculptures.
Oh, wow. So they're like the master sculptors of the AI world.
Exactly.
That's a great analogy. Okay. So what else? What other models?
There's these things called autoregressive models,
Okay.
and those generate data sequentially.
Sequentially.
Like, think of it like writing a story word by word,
Okay.
where each word you choose influences the next one.
Right.
These models do the same thing, but with data, building up these complex outputs piece by piece.
Oh, that's cool. So we've been talking a lot about images and data, but can AI generate text too?
Absolutely. That's where natural language processing comes in,
Okay.
or NLP for short. It's all about teaching computers to understand and generate human language.
So AI that can write poems or translate languages?
Yeah, or even have conversations.
That's amazing.
And just like in other areas of AI,
Math plays a crucial role.
it does. Our source talks about two main approaches: Markov models and transformer models.
Okay, I'm ready to hear about how AI is learning to speak our language.
Great, so let's start with Markov models.
Okay.
They're based on a simple statistical method,
Okay.
where the next word in a sequence is predicted based on the previous word. or a few words before.
Like a word prediction feature on your phone.
Exactly.
Okay, so it's like AI is guessing what you're going to type next.
Yeah, it's a pretty clever approach.
But it probably has limitations, right?
It does. They have kind of a short-term memory. They can't really capture the long-range dependencies and complex grammatical structures of human language.
Right.
So that's where transformer models come in.
I've heard those are kind of a big deal.
Yeah, they're the stars of NLP right now
And why is that?
because they've got this self-attention mechanism that allows them to understand the relationships between words, even if they're far apart in a sentence.
Oh, wow.
They can really capture the nuance and context of human language.
So it's like they can read and understand a whole paragraph, not just a few words.
Exactly. And that's what allows them to do things like machine translation, text summarization, and even creative writing.
Really creative writing.
Yeah, poems, code, scripts, even musical pieces.
Whoa, it's like having an AI Shakespeare.
That's a great way to put it.
So how does this self-attention actually work?
Well, it involves a lot of calculations
Yeah.
that figure out how much each word relates to every other word in a sentence.
Oh, wow.
It's like the AI is carefully analyzing every connection and weighing its importance.
That's crazy.
It takes a lot of computing power, but the results are really impressive.
Yeah, so AI can now really understand and generate human language in a way that seemed impossible just a few years ago.
It's pretty amazing how far we've come.
It is. It really is. So we've talked about GANs and VAEs, normalizing flows, and autoregressive models. Are there any other important types of generative models we should know about?
Well, there are a few others, but I think it's more important now to shift our focus to how these models are actually being used in the real world.
Yeah, let's talk about that.
Because we've talked about AI making art and music,
Right.
but there are so many other practical applications that are changing the game in all sorts of fields.
I'm all ears. Let's hear it.
Perfect. Well, one area where generative AI is really making a huge impact is in image generation and transformation.
Okay.
Like, think about those apps that can enhance blurry photos,
Right.
or even generating these hyper-realistic images for video games or special effects in movies.
So AI can help us see things more clearly or even create entirely new visual worlds.
Exactly. There are even techniques now, like style transfer,
What's that?
where you can take the style of a famous painting and apply it to a photograph.
Wait, so I could make my vacation photos look like a Van Gogh.
Pretty much.
That's so cool. And it's not just visuals, right? What about text?
Yeah, generative AI is revolutionizing text generation and summarization, too.
So like AI writing news articles or summarizing long reports.
Exactly. Imagine being able to have AI condense a huge document into a concise summary.
That would save so much time.
It would be a huge productivity boost. And remember those transformer models we were talking about earlier?
Yeah, the ones
Yeah.
that are so good at understanding context.
Exactly. They're perfect for text summarization.
That makes sense.
And they can also be used for other kinds of creative content, like poems, code, scripts, all sorts of things.
It's like having an AI assistant that can help you with all your creative work.
Pretty much.
Yeah.
And the applications go way beyond the creative realm, too.
Oh, really? Like where?
Generative AI is being used in scientific research and data synthesis as well.
Now we're talking. Tell me more about that.
Well, one way is by generating synthetic data for training machine learning models.
Synthetic data. What's that?
So real-world data can be hard to come by or expensive to collect,
Right.
but generative AI can step in and create realistic synthetic data to fill those gaps.
Oh, that's clever. So it's like AI is helping to accelerate scientific discovery by giving researchers more data to work with.
Exactly. And it's a really powerful tool for fields like medicine.
Oh, how so?
So researchers can use this synthetic data to train models for things like disease diagnosis
Oh, wow.
or drug development without having to wait years to collect enough data from real patients.
That's incredible. So we've seen how generative AI is being used to create art, write text, summarize information, and even advance scientific research.
And those are just a few examples.
Yeah, it seems like the possibilities are endless.
They really are. The applications are constantly expanding and evolving.
This deep dive has been amazing.
It has been a fascinating journey.
We've learned what generative AI is, all the math that makes it work, the different types of models, and the incredible ways it's being used.
We've come a long way from that basic definition to seeing how AI is pushing the boundaries of creativity and innovation.
It's clear that generative AI is a powerful tool that has the potential to really change the world.
Absolutely.
Yeah.
But like with any powerful tool, we need to think about its impact and make sure it's used responsibly.
Right, of course. But overall, I'm really excited about the future of generative AI.
Me too. It's a future where the lines between human and machine creativity will keep blurring.
And that will lead to all sorts of amazing new things.
New forms of art, new scientific discoveries, new ways of interacting with the world.
It's mind-blowing.
It is.
Well, thanks for joining us on this deep dive into the world of generative AI.
It's been a pleasure.
We hope you learned something new and you're as excited about the future of this technology as we are.
Absolutely.
Thanks for listening. Okay, so we left off talking about going back in time to see how AI has evolved. So where do we start?
Well, the earliest forms of AI, like back in the 50s and 60s,
Yeah.
were what they call symbolic AI.
Okay.
And these systems relied on a set of predefined rules and symbols
Okay.
to try to mimic human reasoning.
So like teaching a computer to play chess by giving it a rule book.
Exactly. That's a perfect analogy. But symbolic AI had its limitations.
I bet.
It really struggled with the complexity of the real world and all its ambiguity.
Yeah, that makes sense.
And then in the 80s and 90s, neural networks came along.
Oh, yeah, I've heard of neural networks.
They're kind of inspired by the structure of the human brain.
That's cool.
Yeah. And they revolutionized AI by letting machines actually learn from data.
So this is where AI actually learning from experience really took off.
Exactly. It was a huge shift.
Wow.
And a key breakthrough during this time was the invention of this algorithm called backpropagation.
Backpropagation. Okay.
Yeah, it allowed us to train these neural networks so much more effectively
Oh, so.
by adjusting the connections between these artificial neurons based on the errors they made.
So before backpropagation, it was really difficult to train these complex networks.
It took forever as a major roadblock.
Wow. So backpropagation was a game changer then.
It really was. It opened up a whole world of possibilities for deep learning. And then the 2000s saw the rise of machine learning and all these data-driven approaches. So AI became less about programming rules and more about letting the algorithms find patterns in the data.
Right. That makes sense.
And that brings us to the 2010s and the present day, the era of deep learning and massive data sets.
Yeah, this is our era.
Exactly. And this is where things get super exciting with generative models like Jan's taking center stage.
Jans, I've heard so much about those.
They're really fascinating.
They are. Those are the rock stars of AI creating new data, right?
They are, and they're really interesting how they work.
How do they work?
So imagine you've got two AI models engaged in this constant creative duel.
Oh, wow.
It's basically you've got this generator network
Okay.
trying to create realistic data, and then you've got a discriminator network
Right.
trying to tell if the data is real or fake.
Okay, got
The
it.
generator's trying to fool the discriminator. The discriminator's trying to get better at spotting the fake.
Gotcha.
And this back and forth competition just pushes both networks to improve, and you get some amazing results.
Wow, so they push each other to get better.
Exactly.
That's amazing. And Jans are behind some of the most impressive AI stuff we're seeing.
Yeah, like those photorealistic images.
Right, those are incredible. And then our source material also mentions another type of generative model called VAEs.
Oh, yeah, VAEs.
Yeah. How are those different from Jans?
So instead of a creative battle, it's more like they're code breakers, master code breakers.
Interesting.
They learn to compress the data into a smaller representation,
Okay.
almost like a secret code.
Got it.
And then they can use that code to reconstruct the original data.
Huh.
And through that process, they learn how to generate new data that's similar to what they were trained on.
So it's like they're learning the essence of the data and then using that knowledge to create something new, but similar.
Yeah, that's a really good way to put it. They're good at generating images, reconstructing missing data, even detecting anomalies.
That's really useful.
It is.
Yeah.
But there are other types too. Our source mentions these things called normalizing flows, which are a bit more complex, but very powerful. They involve transforming these simple probability distributions into more complex ones
Right.
to model real-world data in a more accurate way. It's kind of like,
Can you give me an analogy?
yeah, so imagine you have a lump of clay.
Okay, I've got my clay.
It's easy to work with, but you're kind of limited in the shapes you can create.
Right. I can only make so many things.
Exactly. So normalizing flows are like this set of tools that lets you mold that clay into incredibly detailed and intricate sculptures.
So they're like the master sculptors of AI.
Exactly.
That's a great analogy. Okay, what other models are there?
So there's these things called autoregressive models,
Yeah.
and they generate data sequentially.
Okay, sequentially, what does that mean?
Think about writing a story one word at a time,
Okay.
where each word influences the next word.
Yeah, that makes sense.
These models do the same thing, but with data. building up complex outputs piece by piece.
Oh, that's cool. So we've talked a lot about images and data, but
hmm
can AI generate text too?
Oh, absolutely. That's where natural language processing, or NLP, comes in.
NLP,
It's
yes.
all about teaching computers to understand and generate human language.
So AI that can like write poems and translate languages.
Exactly. Or even have conversations with us.
That's amazing. So how does AI learn to speak our language? Like what's the math behind it?
Well, just like in other areas of AI math, plays a crucial role.
Makes sense.
Our source mentions two main approaches: Markov models and transformer models.
Okay. I'm ready to hear about how AI learns to speak our language.
So we were talking about all these different types of generative models and,
Yeah, like JANs and VAEs and all those things.
right, all those different approaches. But I think it's good to kind of shift our focus now to how they're actually being used, in the real world.
Yeah, hey, let's talk about that. We've been talking about AI making art and music.
Right. And those are amazing applications, but there's so much more.
Right.
Generative AI is changing the game in all sorts of fields. Like, one big area is in image generation and transformation.
Okay, so like what kinds of things?
Well, think about those apps that can enhance blurry photos,
Right, right.
or, generating super realistic images for video games,
Oh, yeah.
or special effects in movies.
So AI can help us see things more clearly or even create entirely new visual worlds.
Exactly. There's even these things now like style transfer.
What's that?
You can take the style of a famous painting and apply it to a photograph.
Whoa. Wait, so I could make my vacation photos look like a Van Gogh?
Pretty much.
That's so cool. So it's not just visuals, right?
No, generative AI is also changing how we work with text, like text generation and summarization.
Oh, so like AI writing news articles or summarizing like those super long reports that nobody wants to read.
Exactly. Imagine being able to have AI condense a huge document into a nice, concise summary.
That would be amazing. It would save so much time.
Right. Talk about productivity boost. And remember those transformer models we were talking about?
The ones that are really good at understanding the context of language.
Exactly. They're perfect for text summarization.
That makes sense. So they can read a whole paragraph and understand what it means.
They're really good at that. And they can be used for creative content too, like poems, code, scripts, you name it.
It's like having an AI assistant that can help you write.
Yeah, pretty much. And it goes beyond the creative stuff too,
Oh, really? Like what?
like scientific research and data synthesis.
Oh, wow. Okay, tell me more about that.
So one way is by generating synthetic data for training machine learning models.
Synthetic data, what's that?
It's basically artificially created data,
Oh,
because sometimes real-world data is hard to get or it's really expensive to collect.
right.
So generative AI can create realistic synthetic data to fill those gaps.
Oh, that's a clever workaround.
Yeah, it's pretty cool. So AI is basically helping to speed up scientific discovery by providing more data to work with.
Oh, that's incredible. So we've seen how generative AI can make art and write and summarize information and even advance scientific research.
But those are just a few examples.
Yeah, it seems like the possibilities are endless.
They really are. The applications are constantly growing and evolving.
Well, this deep dive has been amazing. I've learned so much.
It really has been a fascinating journey, going from that basic definition of generative AI
Right.
to seeing how it's being used to push the boundaries of creativity and innovation.
It really is amazing, and I think it's clear that generative AI is going to have a huge impact on the world.
Yeah, I agree, but like with any powerful tool, we need to be mindful of its implications.
For sure, and make sure it's used responsibly.
Right. But overall, I'm incredibly excited about the future of AI and all the amazing things that are going to come out of it.
Me too. It's mind-blowing to think about all the possibilities.
It really is.
Well, thanks for joining us on this deep dive into generative AI.
It's been great chatting with you.
We hope you learned something new and are just as excited about the future of this technology as we are.
Absolutely. It's an exciting time to be following this field.
Yeah, it really is. Thanks for listening, everyone.